So we have our stopper. So, it's a good idea always to maybe sketch out a picture. Here's our stopper. Going in a circle. Okay, our radius was 68. Our mass was 12. Alright, and then we went 10 times, 10 revolutions in 7.5 seconds. Yeah?
You said that was 68, so
This would be the radius, right?
but I thought you said the radius was
Oh, okay, good. So that's a good point. So one of the first things you do have to do is make sure you convert that, right? So 68 centimeters, before we start doing the math on this, what should we change this to? Change it to meters. So that's 0.68 meters. And there's another conversion we need to make. What's that? We need to go to kilograms, right? So we can do that. We can do that straight away. It's always a good idea. So 12 grams is how many kilograms? So yeah, always make sure eventually that you make the conversions, and doing it right off the bat is always a good idea so you don't forget. Okay, so let's do these. So letter A, actually letter A shouldn't be too bad. How are we going to find A? Yeah, we know the time for 10, so how would we find the time for 1? Divide it by 10. Yeah, so it's easy enough. So we're just going to go T. So the period, the symbol we use for period is a capital T for time, because period is a time. So we'll just go, all right, the time is 7.5 seconds divided by 10 revolutions. And why do we do that? Why did I do that? Why didn't I just have her time it for 1 revolution? Yeah.
because we needed to have more of an average so we could
Yeah, we're basically kind of taking an average here, and so doing it for multiple times, it's the same thing as if you do multiple trials, and it's going to narrow it down. So this is 0.75, right? So that's the answer. That would be the period, 3/4 of a second. Okay, let's find the velocity. Now I did give you an equation with velocity in it. However, what are we missing from that equation? Acceleration. So that's not going to be enough. Anyone know how we do this one? Yeah?
use the well, you have the time click, and then you have the can you find the distance from because you have the circumference.
Alright, good. So we're going to use like an old school day 1 equation, right? Velocity is distance over time. And the distance for 1 revolution is how far? What do we call this when you find the distance around a circle? The circumference. Yeah, so the distance is the circumference. So that's exactly what we're going to do. We're going to find the circumference around our circle and divide it by the time for 1 revolution. And what's the equation for circumference? 2 pi r. Alright, so again we're just saying, oh, well, if we know the distance in 1 revolution and we know the time it takes, then we could go ahead and find how fast it's moving. Okay, so go ahead and do that. 2 pi, and again, make sure you use your converted distances. 0.68 meters and 0.75 seconds. About 5 point something. Alright, And at this point, it should be pretty straightforward of where we're going to go from here. So how are we going to find the centripetal acceleration? Okay, we'll just use the equation v squared over r. Around 50, something like that. 47.8 meters per second squared. Alright, and lastly we're going to go ahead and find the tension. Well, notice in our picture, the tension is this way, right? T. And there's no other forces involved here, so like if we did our FBD, we just have our tension. And if we did our summation, we just have one, tension. Well, what is force equal to, or what is tension equal to? Mass times acceleration. Right? And if you want, you could subscript this C, since it's a centripetal acceleration. So we're simply going to multiply the mass by our acceleration. Less than 1, 0.7, 0.6, point what? 6.
No, 0.57.
57, no, 6.
574.
Okay, so that would be our tension.